Okay, and welcome to part 2 of the build for this QDX transceiver. So we're on step 2.9. We're going to prepare and install Tapped Inductor L12. So the first thing we got to do is take some of this wire. We need 75 centimeters. That's 30 inches. So I'm going to get a bunch of this. Measure out 30 inches. There we go. Okay. And we want to wind this. Is a multi-tapped toroid. So we're going to wind it. I don't know which direction you call this, but this way, like counterclockwise around. So this is one turn. So every time through the center is a turn. So we're going to go around 19 times before the first tap. So that's 1. This is 2. Three. Don't be afraid to pull it tight. 4. 5. 6. 7. 8. 9. 10. Wait a minute. Did I do that right? One, two, 3, 4, 5, 6, 7, 8, 9, 10. That's not what you want to do. You do not want your wire to get kinked. It's really hard to get out. 12. 13. 14. 15. 16, 17, 18, 19. Okay. So that is a tap right there. So we can now check it against the PCB here and kind of dress out. Oh wow, that's like, wow. I can't get much closer than that. Okay, so that looks pretty good in terms of spacing. I'm shocked. Cool, okay. So I'm gonna drop the instructions. I'm gonna just count these real quick, because I'm paranoid. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so we're good. So that's 19. So what we're going to do is leave a little bit of a loop right there and keep going. So now remember, this just going through the hole here counts as a loop. So just going back through is 20. 21. 22. 23. 24. 25. 26. 27. 28. 29. 30. Okay, that's our next tap. So again, we're going to check where we are here on the PCB. That looks pretty good to me. I think that's going to line up nicely. Okay. So we can, if you've got good eyes or a loop, one of these deals, you can double check your work. 20, oh, this is really hard. It's getting really hard to see. Okay. Okay, let's see. See if I can count them. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Double checked. All right. So this is another tap. And we need to get to 41. So this is 31. 32. 33. 34. 34, 35, 36. Okay, so now we're getting a little bit tight here. It's okay. We got room. We can push these down a little bit. Okay, so ideally you should have this, these turns should be very close and evenly spaced. What did I say? 31, 32, 33, 34, 35, 36. Okay. This is going to be 37. Okay, 37, 38. Ah, that's not what you want to do. You want to pull it tight, but you can't pull out your loop. $39. 40, 41. That looks pretty good. Okay, so now you can see how they should line up. This is the first hole, that's tap 19, tap 30, 36, and 41. Cool. That lines up like perfectly. Happy with that. Okay, so now I just need to scrape the enamel off this and then get it soldered up. So you know what? We're actually, I'm not going to scrape the enamel off like I usually do because I'm reading the instructions and Hans says that he just solders it and the solder burns away the enamel. That's not worked for me in the past, but let's give it a try. I'd be very disappointed if it doesn't work, but I also trust, this isn't the wire that I have, so maybe it's different, and I trust this these instructions. So okay, so I'm just making a point that I can get these wires through the PCB holes. They're not super big. Okay. Should be enough. Okay. This is going to be tricky, I think. The holes seem unnecessarily small. I feel like we could have gotten away with a little bit more room to get these components and wires in. I don't know if there was a reason for going this small with the holes. Okay. Believe everything's in place where it should be. So now we gotta just... Nope, that battery is dead. Okay, so I've put the toroid on here. I pulled the wires through. I think it looks pretty good. I don't know if I can get much better than that. I'm pretty happy with that. Nice tight loops. They look like the spacing's pretty decent. I could probably tidy them up a little bit after I solder. So I'm going to go ahead and try just straight up what the instructions say. And I'm going to lay this down. Start with one of these here. And see if I can't just put a big old blob of solder on here. And melt off the enamel. That seemed to work. I'm really surprised. We'll see what happens when we get to these other ones. Actually, let's do this one next. So this one here is the opposite of the first one. Oh yeah, that helps. Yeah, so that seems to be working. I'm surprised. I'll just keep going around and doing that. So I'm going to tighten up this last couple here. Give them a trim. Alright, so that one didn't work quite as well. I wonder I wonder if it has to do with the temperature. So I'm what do I have mine set at? About 630 Fahrenheit. Where am I at here? Right here. Okay. I guess that worked. What's on there? Reflection. Okay. Ah, it's coming along. Let's see. There's probably a step here where we check continuity. I feel like that would be the next logical thing. Yes, verify the joints are properly soldered using a continuity testing. Continuity between 3, 4, 5, 6, and 9 of IC3. Interesting. Okay, so 3, 4. Three, 4, 5, 6, 3. Come on. 3, 4, 5, 6, and 9. Looks good to me. Here's the story so far, including the nicely installed L12 tapped inductor. It does look nice. I like it. All right, so where are we? We are on step, what is this? 2.10, 210. Whoa, where'd my wire go? Ow! Just hit my head on my desk. Okay, so we're winding and installing L14. So L14 goes over here. And this is an FT3743 toroid, which I recognize as being one of these. So we need 10 turns of the thicker wire. So we're gonna, just like the other ones, it's 1. This one is probably, because this is the thicker wire, it's 10 turns on a FT3743. I'm thinking this is probably the RF choke for the DC supply to the finals. So, what was that? 2? 1, 2. Oh, it's a lot harder with this thicker wire and this small toroid. So this is basically just blocking the RF from going back up the voltage rail, if this is what I think it is. So the turns actually on this one probably aren't as critical, but for this thicker wire, I find it helpful to kind of bend it like that, and then again guide it through the hole so it doesn't get scratched on its way through. One, two, three, 4, 5. Six. Seven. 8. 9. 'Oof. I think it'll be okay, but oh, come on, focus. Jeez. I don't know if you can see it there, but I did nick the outer wire just a little bit. So, oh, and this you can see I scraped a little bit of the enamel off here. Oh well. Like I said, if this is, it's over here. Let's see. Oh yeah, for sure. It's the RF choke to block the signal from going back to the DC rail. So I think it's a little bit less critical. So now let's see here. I guess these are meant to be installed upright, so this makes sense. Just gonna space out these coils. That looks pretty good. Okay, so what's interesting, so I'm gonna snip this just a little bit. Is the instructions the instructions do say to scrape the enamel off. So it seems like this thicker wire, you do need to scrape off the enamel, which is my experience. I was really surprised that that thinner wire, I didn't need to. Okay. So get that in there. Man, it is tight. Looks pretty good. Get that soldered up. Okay. L14 done. Okay, low pass filter toroids. Okay, so we have 6 of them. Okay. And here's what they look like. So, two types and 3 or 4 6 types. So size 37, that's what the T37 is, dash, and 2 is the material that they're made out of, and that depends on the frequency range that they handle. So T37-2, a couple of them, those are the red ones, and then T37-6 are the yellow. So this is simple. I mean, we just have to... What is this other T37-43? Oh, that's the yeah, that's the input transformer. That's Trifilar wound, so that's the last one. So these ones are pretty straightforward. So let's see. They give us wire length in centimeters. So let's see, L2. I guess we'll just do these one at a time. So we're going to measure out a length of wire. And my tape measure, because I'm in the States, doesn't do metric, so gotta convert 36 centimeters. It's like 14 inches. So L2 L2 24 turns on the red. That's 1. 2. 5. 6. 15. 16. 17. 18. 19. 20. 21. 22. 23. 24. Lots of wire left over. Okay, so I went pretty fast on that one, but maybe I could have done this a little bit tighter. Doesn't look too bad though. Okay. Pretty sure I did this right, but I'll count really quick. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24 turns. Okay, so this can go L2. So I'm just going to do these, put them right in. Make sure L2, just double checking. Where's 5? L6, L8, L10. Oh, the other side? Yeah, those inductors we're going to have to replace. So, yeah. 24 turns. Okay, so and when winding these, you can basically pull as hard as you can, and that's fine. As long as you don't break the wire, of course. Yeah, that kind of works. My freaking soldering iron is falling apart. I think I might go back to scraping these though, because it just seems like takes an awful lot of heat to get these and solder. Oh man. So what happens is, although it is removing the lacquer from the magnet wire, it basically just makes a bigger mess of flux, because that's what the flux is, kind of what removes the lacquer, takes it away. Looks okay. Yeah, I think for the next ones I'm probably going to scrape. Okay, so this was 80 meters. It's part of the 80 meter filter. What's the next one? Also part of 80 meters, so this is L6. It is 39 centimeters. What's 39 centimeters if 36 is 14 inches? Another inch. So let's see, 15 inches? Okay, and this one is, 26 turns. Okay. Let's see if I can do this one even tighter. 2, 3, 4, 5, 6, 7, 8, 10, 12, 13, 14, 1, 2, 3, 24, 25, 26. Still so much wire left. That's pretty good. I like this. I think it looks nice. Alright, that'll do. So let me just I just have to double check.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26.
Looks good. Yeah, so gonna scrape these. I mean, it doesn't take that much time. Even if I just get a couple sides. The worst thing would be if you pull this at the wrong angle and you end up just cutting the wire. Okay. So which one is this? This is L6. Well, L6 is up here. Okay, so we're going to go up here. Okay. Oh, that's not good. Alright, so I bridged that connection by mistake. That's tough. That's close in there. For all I know, that actually looks like they might actually be yeah, they're on the same trace, so it wouldn't have mattered, but that's okay. It's nice and clean. Okay. Next up, L3. It's getting easier. Let's see. Okay, so L3 is 29 centimeters. That is 11.5 inches. This is a yellow L3. We want 18 turns. 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Looks pretty good. Again, big tail, lots of extra. It's good because it gives you something to hold on to. It can be kind of tough at the end. Okay, what was this one again? 18? Did I say 18? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yep, 18 turns on the yellow is L3. L3 goes down here. It's tough to get these. You want to center it, but you also kind of want to take up any slack from the leads. It can be tough to get both of those things. So worry more about getting them centered. looks pretty good. Three L8, 20 turns, so 30 centimeters, or I mean, it's about the same, right? It's about 11 and a half. One, two, three, three, four, six, seven, eight, nine, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, Okay, this was L8. L8 goes up here. If we didn't want to use the 30 meter or 20 meter bands, we could just stop here. But we have two more for the 30 and 20 band filter. Okay. L4. 11 turns, 20 centimeters. So 20 centimeters. It's a little under 8 inches. So 7 3/4 inches maybe. $11 turns. That's it? 11? Piece of cake. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11. We can dress this out a little bit more. Okay. So much wasted wire. Okay, so this again was number L4. L4. L4 is down here. What on earth is happening up there? Ah. Dirty flux. Okay, one more, and then our low pass filters are done. And we need, where'd my wire go? About 8.5 inches. So we're going to do 13 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, did I miscount? 1, 2, 5, 6, 7, 8, 11, 12. I sure did. 13. This is why I double check. Looks good. Okay. It's L10. Okay, just need to solder this. Oh, isn't that pretty? All right, so that took, what, about an hour? 45 minutes? Closer to an hour, probably. These are all really wiggly just sitting here, and when I have this circuit all complete and I know it's tuned and working and stuff, what I might do is come back. I have some of this stuff. This is called Q-dope, and this is it's basically just it's polystyrene dissolved in methyl ethyl ketone, and polystyrene doesn't have any effect on transformers or inductors. It's doesn't affect the Q or why is this? There we go. Yeah, so it doesn't affect the operation of the inductors or transformers at all. But what it does do is it keeps all of these coils and everything nice and tight and keeps them from vibrating, because believe it or not, the coils vibrating or moving or you know, you tap this around or whatever, that mechanical movement can actually affect the circuit. So you'll actually get, you know, interference in the circuit from that mechanical. So the Q-dope basically just stabilizes everything, makes it a little bit more stable. Nice. Low pass is done. So time is it? Oh, okay. Gotta take a break. My playtime is over. Gotta go do the bedtime routine. Okay, so now it's time to ooh. All right, excuse me if I sound a little bit different because it's the next morning. I had to pause, and now we can resume. So now we are going to wind the Trifilar Toroid. So let's see. And do the conversion here from centimeters again to inches. So the instructions say we need 3 pieces of this. Hopefully there's enough left. 20 centimeters long, or just about 8 inches. So it's gonna be close. Let's see if we're left with that much. In fact, probably could have just let's see if I bend these in half. Let's see how long this is. Yeah, okay, so we're just about there. Now I'm going to do something a little bit different, because I have this green wire and I just like the way it looks. I wish, let's see, I only have red and green, but I like the look of when you wind this together. You end up with more than just one color of the wires. Yeah, and I do this a little bit differently. I'm not going to use a manual thing here. I'm just going to use a drill. So this is much faster, I find. So let's see if I can focus this camera. Okay. All right, so I'm just going to put this whole thing in the drill like this. Oh, wrong way. sideways, so it twists everything. Okay. And now, I think I could just, I'm trying to remember how I did this last time. I think it ends up being better if you hold the end. Let's try. Let's just try it. Yeah, so it actually will be a little bit easier to hold this end with like a little screwdriver or something. I got a drill bit right here handy, so I'll use that. A little bit more. Looks pretty good. There's one spot where it looks pretty good. I mean, so the whole purpose of this is to just tightly couple the three wires. The actual twist, it's just more for closely coupling these wires as they're twisted on the toroid. I found that the kind of twist that's in here, and it's not very critical, and it says that in the instructions. Alright, so now that we have this, you can kind of get rid of some of the end here, just to make it easier to wind our toroid. This end we're going to, let's kind of just leave it like this, because we're going to need to separate them out anyway later. There's one spot there. It didn't really want to twist very good. You kind of play with it, but I don't think it's going to matter too much. It's weird. A little kink or something. Alright, so this is a 10 turn. So we're going to go through 10 turns. So start here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Probably should have started with this end because this was the nicer one, and the kink probably would have ended up towards the end. I call it a kink. It was just kind of like a one turn that didn't quite turn as well. Let's see if you can even see where it is. Yeah, kind of, it's right there. It's very hard to tell. I think this will be totally fine. Yeah, so I added the screen. I mean, obviously you don't need to add wire because there is there's enough in the kit. Just enough though, so don't screw up. You might want to, in fact, you might want to have some spare wire on hand for this, especially if this is like your first build or whatever. And so I think my green wires actually feel slightly thicker. It's okay though. Okay, so what we're doing here now, we just have to untwirl these. And we're going to scrape off the enamel. Just gonna straighten them out. Okay. All right. Obviously, be careful doing this part with an X-Acto knife like this. This one just happens to be pretty dull. You don't need something super sharp to do this. There might be a faster way, but this seems to be the most straightforward that I've found. So the instructions actually say to tin the ends of the wire so that you can measure them with the multimeter. And then you're going to snip those off, I think, for installing this into the board. Let's see. And you probably don't have to do this step either. You could probably just burn off the enamel like the instructions say. But I like to do this anyway, because I feel like the burning the enamel off, you have to hold the heat on there longer. I'm still going to have some that's burning off. I'm not going to get every little bit. but it'll be less, and it'll give the solder a chance and the flux a chance to see bare copper quicker. So that'll mean just a better joint, I think. Okay, so now let me get my multimeter. Obviously, the green and the green are one pair. Jeez. Right. So then we got to match the other red ones. And looks like I probably, by chance, got him. Well, that one moved. Go like this. What do I do? Yeah, okay, so now let me just make sure no conductivity between the three, and just to double check that the inside correct. Yeah, okay, so this is in the right arrangement. So now we can put it into the board. Okay, so refer to the diagram. Show you where I'm at. Check for continuity, blah, blah, blah. And you're satisfied. Okay, so the diagram shows A, B, B, C, C. So I have it this way. But we need it to be flipped. So it needs to be this way. We can double check one last time, make sure. And mess this up? I don't think I did. Yeah, that's right. We'll check one last time after this is installed. Alright, so now this is focusing. Focus. But it's in focus. Okay. Oh, go in there. Where'd my pliers go? Wow, there's a lot of stuff around this. Okay, looks pretty good. While my soldering iron is heating up, we'll try one last time to check. Make sure we're good. Yep. Okay. Yeah, so even with scraping off a lot of the lacquer, you can it's probably can't see this on camera, but looking closely, I can tell the solder doesn't want to just go all around the wire, and you really have to hold it there for a long time to burn off any residual bits. Okay, we want to be really careful right here. I'm actually trying to get it to take to the wire and then bring it down to the pad on the board. I guess this one I didn't do a great job at scraping the insulation off. Okay. This one either. Okay, wow, this is getting tricky. Haven't finished my coffee this morning. I think that's good. Let me take a... I'll trim these off first so I can get a better look. Got this chip kind of hot. I don't like that. Oh, those look like great solder joints though. Man, it would be so easy to bridge to this, well, any of these surface mount components right here. Be super careful here. This is, I could see this going bad. And it's really hard to get these surface mount components back on if you accidentally lift one off with a big blob of solder. Yeah, and this chip here, what is this? This is a... I don't know what chip that is. 3253. Oh, that's probably an analog multiplexer. So the end of it got a little bit warm just from how long it took to solder there. So hopefully that's okay. I think it is. I don't think that's actually an issue, but okay. Are we done with inductors? Well, I think we're done with the ones that we wind ourselves anyway. Continuity check, sure. Should that be? One of them are conductive across. I could look at the schematic. I don't think I did anything wrong. Those are conductive. Those are conductive. Yeah, so the instructions even say, there are numerous surface mount components in the vicinity, so be very careful when soldering the wires of Toroid T2. Do not touch any of the surface mount components. Yeah. There should be no continuity between IC4 pin 7 and IC3 pin 8. Well, IC4 pin 7, IC3 pin 8. 1, 2, 3, 4, 5, 6, 7. So these two should not conduct. Yeah, I think we're good. Oh boy. We're on to the LED, so I think we're in the home stretch. Shorter the two wires and bend it straight down. Okay. And then we can take the other one. You can see this. So that one's pretty much bent. Straight down. And then this one will go like that. Okay. Let's see, and does it rest right on the board? I think so. Okay. Okay, that looks nice. Connectors. Oh boy, here we go. All right. Let's see, what do they want us to do first? I don't think it matters. Let's do the USB. These are nice. It's gonna be easy. Let's see. Nice to take a break from having to be super careful. Just gob on a whole bunch of solder until it fills this big hole here, holding on the USB connector. This is mostly, well, it's some grounding, but it's mostly mechanical to support the connector on the board. I'll do the wires. Oh man, so nice when you have plated back to plated wires on a fresh circuit board. So easy to solder. Perfect. Just keep going. We'll do the just go down. Man, so funny that come to think of it, I think it's gonna be okay, but I probably would have done the DC jack first because it's a little bit shorter. And I think we want it centered in the holes. It doesn't really say. Lots more slop on this one. I'm surprised. So I'm gonna get this. Lots of solder in this joint, and then I just gave it a little bit of a push. Let's see. Just peeking over the edge of the board, so I'm just gonna like pull it back just a little bit. There we go. I don't know if that's right, but it's right at the edge of the board, nice and flat. That looks nice. I like that. Lots of solder. Even more. This original one could probably use a little bit more. That's not going anywhere. BNC connector goes on. I'm going to take this off for now, so it'll sit flat. I think the nice thing about this is all the connectors have the same height, it looks like. So it actually, yeah, makes it easy. Sometimes when you're doing a board, if you have two connectors that are higher than like this one, so like if these ones are higher and you did these first and this one wasn't as high, you can't just flip it over because it would just fall out. So this seemed to work out really well. looks good. Tiniest bit of splatter right here. Okay. Power supply capacitor. We're running out of parts. This seems like it was an afterthought. Oh, right, we need some decoupling here. Yeah, because they want you to do... Darn, you know what would have been nice is if I would plan for this step ahead, because I could have... There's enough room. This could have gone right through that hole. Darn, that would have been nice. So instead what I'm going to do is lift this board up again. Yeah, that works. Well, that works, but this doesn't work so well. Let's see. Okay. And what I'm going to do is, oh man, it's not super elegant, but I got to melt this solder, shove this down through the hole, which I think I can do. Yeah. And we'll kind of just get this into place. Then we got to bring this lead over so we can solder it onto the USB connector. Okay, we don't need all that much, so we just go right there. This I want to just kind of flip around. Give this another heat. Okay, so just by reflowing that a little bit, I ensured that I didn't somehow end up with a cold joint when I pushed that wire through. So I'm going to give this a little tug here. Just make sure, yep, it's on there. It's like the picture. Okay. And, you know, of course, make sure that the negative is going to ground. We have a little bit room if we need to push this back from the edge of the PCB a little bit. I hope we don't. Okay, this part. Wasn't looking forward to this part. So, there are 4 inductors. One, nope, that's, oh yes, 1, 2, 3, 4. We have to remove them. Okay. I'm reading through the instructions here. It says these are easy to remove. Okay, so I'm going to worry about yikes. I'm worried about removing them first. I think I want tweezers. I don't actually have tweezers. I do have some hemostats, but it might work. Let's see. So L1. What would be nice? Okay. So what would be nice is if I can just do one side and the inductor itself conducts enough heat so that the other pad melts as well. Let's try that. I'm going to flip this over this way. Nope. We lifted the pad. Did we? Sure as hell did. Okay, that was more delicate than I thought. Oh man, that is not... It's not happy. Okay, so how do I want to do this? I don't want to do it the same way. Maybe I will try solder wick. I don't know, that's never worked. I'm not going to try and actually lift the inductor this time. L9. Maybe I'll try and push it. So, hard part here is you get one side melted, and then okay, so I've got a blob of, okay, there we go. That's the way to do it. So, oh no, I just scooted over. Oh, it's stuck to the other pad, right? Okay. Got it. So, with a big enough blob of solder, I'm going to clean this up just a bit. Actually, I'm not. Leave it well enough alone here. With a big enough blob of solder, I don't know if you can, I'm zoomed in as much as I can. You get one side melted, then you move over to the other side quickly, and while the first side's melted, you melt the second side and just push the whole thing over. Okay, that was L9. L7 is over here. So I'm going to try and do the same thing. I might have to go back and forth a few times. Oh, nice. Okay. Ah! It's now. Okay. All right. Let's see how we're doing here. Okay, one lifted pad on L1. Not too bad, though. L9's cleanly off. L7. L5. L5. Okay, same deal. Okay, that one. Practice makes perfect, right? That one came right up off with the soldering iron, just surface tension of the solder. Ugh, so much, I mean, it's, yeah. I don't like that there's so much dirty flux just sitting on the board now. I hate cleaning flux off boards, though. It makes me nervous. All right, so that was potentially the easy part. Now we have to use these through-hole inductors to replace those ones. So, so it doesn't matter that we lifted the pad for L1 apparently, because we're going to go really? Man, okay. We're gonna go right to that. I don't like this idea, but right to the resistor above it. I'm going to do that second. My first step, I think, is going to be actually to do the bottom lead to kind of hold it in place a little bit. And let's see, we want to go can go to this where this diode comes through here. Let me. Oh boy. Okay. Sure. Okay. So what we'll do is we'll get it hopefully soldered to this diode here. This is not going to be easy. Oh man. Did we get lucky? So now we don't want it, I don't think we want it to be so much touching the other side of this capacitor, so I'm going to gently lift it up and then push it back down. Yeah. Okay, so now I want to get this lead over to the, okay, over to the resistor. And I'm going to just kind of, oh, I don't like doing this. Yeah. Okay, I think we're there. So what you want to be careful is that you're not, I don't think I am, connected to both pads of L1, because that would totally defeat the purpose. It would basically be like you're shorting out the inductor you just added. So I think we're good there. Boy, okay, so now L9. Boy, okay, so they want the placement to be somewhere like here. And this goes down to over here. Oh no, actually it goes up to the top one. Really? Man, I tell you, probably would have been easier to do this one first, because now this one's kind of in the way. Damn. This is what I get for being first. I get to deal with the oh jeez. Okay, let's just hope for the best here. Just get some solder in the general vicinity. Alright, we'll do this. We'll get extra solder on that pad. We'll get some solder on the inductor, and then we'll kind of just, and we'll just do this, I think. Let's try it. Yeah, that worked. So I kind of used the heat from the inductor lead. So I didn't even touch the, is that another diode? What's that? What is that? That's the capacitor, that's C14. I didn't even touch the lead of C14 directly. Okay, so now this has to go up. We're going to connect this. I don't know why. They say don't use the pads for R9. We'll follow the instructions because I trust them. But I don't know why it says don't use the pad that you took the inductor off. Oh. Gentle. I don't know, I feel like there should be a disclaimer for this, like, know what you're getting into. I mean, it's too late now. All these are sold out. But everybody who got one, hopefully they're good at soldering. Okay, so it says to go to R9 here, even though the pad for the inductor we took off is right there. It's still in good shape, but it's fine. Let's see if we can do this. I think I saw it go. Oh, man, it's so hard to tell if you've made a connection here. No, I don't think I did actually. I did. Saw that one flow. Okay. We're there. We are connected to the top of R9. Okay. What is this? R7, R8, down to there. Okay. R8. Down to right there. I believe. So we're going to do the same thing we did before. So alright, so I need to connect this to right there. So I'm going to make sure there's a whole bunch of blob right there. And get a little bit on the inductor. A little bit. And then just kind of yeah, that worked well. Okay, so we're good there. And this says to go to R8, which is right there. It doesn't seem too hard. I have to bend this down a little bit. Let's see. Okay, so I got this kind of bent into position. Now time to drop a bunch of solder on. Hope for the best. I think I saw it flow. Just to be certain, I could... That pad, I don't know why they don't have us just go right over to... Yeah, no, now it is. So now I'm over to the... connected to the top of R8 and the pad from L7. Okay. One left. This one. Kind of pretty much the same arrangement. Okay, so this should actually be, we just practiced on the last one. So this is the same deal. The board layout for this one is like pretty much the same. So a bunch of solder there. Get some on the lead. Melt it in there together. A little bit more control with pliers. I want this to go down a bit. gonna mess this one up. I don't know. Oh. That's pretty good. And then this one is R7. So same thing as before. I think I'm going to try and do both R7 and I'm going to try and get the pad because it's all one trace. I think that'll be good. So so what I've been doing here is soldering right over the top of R8 and L7, and here R7 and L5, just going right across. Seems to be working. Just like that. Okay, I think we're there. Make sure the inductors are flat against the PCB so there's sufficient space for them to fit in the clearance between the PCB and the enclosure bottom. Yeah. Alright. Okay, so speaking of the enclosure, we're at that step. We're ready. This is the last, well, that's the last page I printed out. I'm so happy. It's come together. These inductors are just floating around there. I don't like that, but I'm gonna leave them for now. Like I said, I think after I make sure this is all working, I'm gonna put a bunch of Q-dope, kind of make these just stick where they are. Okay, so, all right, enclosure, where is it? Screws and panel. And then somewhere here there are feet, but I'm not going to put those on quite yet. Install screws at the bottom left and bottom right of the front panel, fixing it to the bottom half of the enclosure. If the short edges, i.e. LED status edge and connectors edge of the PCB feel rough, it can be a good idea to gently... I'm not going to file the PCB. How rough can it be? I'm going to guess these are number 1 Phillips. Yes, they are. Okay. Slide the PCB in. Oh, look at that. Okay. What do we want to do next? Back panel? Yes. Fit the top half. So there's a tongue and groove deal here, so you have to get them the right way around. Oh God, this is beautiful. So if anyone actually did follow along this entire like 2 video series and build this together, I want to know. I want to know who you are. I'm going to be surprised if anyone actually was able to, you know, follow along and basically do it in real time with me. I mean, that'd be awesome. That's like what I was thinking about, my vision, but I don't actually think it's going to happen. Alright, tighten up these screws. One thing, it says the nut is optional for the RF connector, for the BNC jack. I don't know why, like I think it's good to have on there. It says, oh, you don't even need the washer. Yeah, I kind of agree with that. I don't think you really need the washer. But I'm going to put the nut on because that's the only thing that would hold the PCB to the case. It's just kind of sitting in there, right? So having the nut on, I think, is a good idea. Can't tell if this is focusing. I don't think it is. There we go. So I'm gonna put it on. And this should take some of the stress away from the board, because if this is pulled on for whatever reason, now at least it's mechanically connected to the enclosure, and so the board is just kind of floating in there, right? It's not being stressed by moving the RF connector, and I'll snug it up just a little bit, but I don't think you really need to go super tight on here. I'll just line it up so you can see the label nicely. Alright, well, that's it. We're done. This is complete. It's built. It's a thing. Awesome. Alright, so you know, obviously I need to get a connector made up, plug this in, get it hooked up to the computer, test it out, all that good stuff, but that's not what this video is for. So in terms of this video, I hope you enjoyed it, and I hope yours came out just as well. I hope you're as excited as I am. Man, this is really cool. All right, thanks for watching, guys. We'll see you next time.